reacting to my answers to the first 10 questions in the FMA 2008 exam. Now I'm pretty sure I got all of them wrong. Let's go ahead and check it out. So the first question, asked us about a bird. So we had some kind of a bird flying through air, and it was initially flying at a speed of 10 meters per second, and then it sped up to 18 meters per second, over the course of 40 meters. So the question was, what is the magnitude of the acceleration of the bird? So hopefully I got this one right. Let's go ahead and check out what I got here. Acceleration of bird. And let me
folks,
go to the end of the video and check out what answer I put down.
So 224 divided by 80, number 2.
Alright, so I got 2.8, which is 2.8 meters per second. That's what my final answer was. And 2.8 meters per second squared. And that was choice D. Let's check out if that's the right answer. D it is. Alright, we've got 1 to 0, 1 for 0. So let me just keep my scoreboard here. So scoreboard. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so let's go ahead and check these out. So number 1, we got it right, 1 point. Alright, so next question. Next question is a roach. A roach is traveling along the walls of a cube. So you've got a cube like this, some kind of a cube, and there's a roach that's traveling from the bottom left corner of the cube to the upper right corner. So the bottom left corner is going to be this. The upper right corner is this. That's the max distance, and we got to find out what the length of this path is. So I got a 3√3 if I remember correctly, because each of the lengths of the cube was 3. Okay, so then by the Pythagorean theorem, we can see that we can make this right triangle right here, if you can see that, and the length of this right triangle can be given by another right triangle, which is this one. So this right triangle has lengths 3 and 3, and so its hypotenuse would be 3√2. And this hypotenuse is root 3, or just 3. And so what would the hypotenuse of the whole path be? Well, it would be 3√2 squared plus 3 squared. Root that, and you should get 3√3, which is answer choice C. So hopefully I made the right choice. Let's see if I did.
Okay,
so cubical displacement.
Alright.
So let's see what I got.
Yep. So that's going to be answer choice C.
Alright, so I got choice C. So let's see what that right answer is. Choice C indeed. We got 2 for 0, folks. 2 for 0. Let's keep on moving. So question number 3, what do we have right there? Question number 3 talks about xt graph and converting it to a vt graph, basically. We got to find the instantaneous velocity. So let's do that. Let's find the instantaneous velocity. So we have this kind of a xt graph, and we've got to find the instantaneous velocity at 2 seconds, which should be right about there. So remember, if you want to find the instantaneous velocity, you gotta, from an xt graph, you gotta find the derivative, which is the slope. So that's not too bad, finding the derivative, finding the slope. Finding the slope of this line is as simple as taking 2 points and finding the slope, right? So this point right here is going to be 0, 4. This point right here is going to be 2, 0. So our slope should be -2. And so our answer should be -2. Hopefully I made the right choice. So instantaneous velocity. Let's see what I got.
Alright, folks. Today we hopefully you got to see it.
And so I got choice A, which is -2 meters per second. Cross your fingers. Hopefully that's the right answer. And as a matter of fact, it is indeed choice A, -2 meters per second. So we've got 3 for 0. Let's keep going. Okay, so question number 4. We're asked to find the max displacement for the toy car, the maximum displacement. So you've got a toy car, you wind it up, and it travels some distance, given by this xt graph, I do believe, or vt graph rather, this vt graph, and we've got to find what the maximum displacement of the car was. Now many kids make the mistake that as soon as this velocity starts having a negative acceleration, well, then you start going backwards. But no, when the velocity is negative, you start going backwards, and that only happens in this latter portion. So your maximum displacement should be right before your car starts going backwards. So you just gotta find the area under this curve. Okay, under this curve. Let's see if I can still do that for you. So what do we have here? We've got two shapes. Number one, I have this trapezoid right here, and number two, I have another trapezoid, this trapezoid right here. So what are these lengths? Let's figure them out. First and foremost, this right here is 2. This right here is 1. This right here is 2.5. 2.5, sorry. 2.5. And this right here is 2. Okay, or rather 1.5. 1.5. 1.5. I'm just looking at this graph over here for 1.5, 2.5, and it ends right over here at 3. Okay, at 3. Okay, we're almost there. Do we need any other information? Yes, we do. We need the maximum velocity, which turns out to be 4. Turns out to be 4 meters per second. And now we finally have enough information to calculate the total displacement. So let's go ahead and do that. So let me get my yellow pen. The yellow pen, and now we can use the area of a trapezoid, right? The area of a trapezoid is the average of your bases times, of course, your height, right? Your height h. So what's my base here? My base is 2 and 4, so that's going to have an average of what? Half of 2 plus 4 is going to be 3. And what about my height? My height is going to be 1. So that's just going to be 1 over here. So times 1. And so the area over here is just going to be 3. Let's keep on going, folks. How about here? Well, here we've got another trapezoidal shape. So we've got half the average of the bases, or rather the average of the bases times the height. So my base here is what? That's going to be 1.5 plus 0.5. So that's going to be 2 in total. So half of 2 times our height. What's our height? That's going to be 4. And well, so that gives us a total of 4 for the area under that trapezoid. And so if you sum up these areas, 3 plus 4 is, of course, 7. And let's see if that's an answer choice. 7 meters. As a matter of fact, it's D. Let's cross your fingers that I made the right choice before. Maximum displacement. And let's get these abs. Let's see what I got for max displacement. And so indeed I did get 7 before, and so I must have chosen the same answer, which is choice C, I believe, so, or choice D. Good. Did I pick choice D? Yes. Okay, good. So let's see if the correct answer is actually choice D. And as a matter of fact, it is, huzzah, and that gives us 4 for 9. 440. Let's move on to question number 5. Hopefully I got that one right. Question number 5. Let me write 5 nicely here. So question number 5 asks us which one of the AT graphs most closely represents the acceleration of the toy car. So what we're going to do is just convert this VT graph into an AT graph, which is not too hard. All you need to do is find the acceleration at some time intervals. The acceleration here, well, what is that? Find the slope. Well, this right here, this point is 1, 4, and this point right here is 0, 2. Find the slope between those 2 points. What is that? Well, it's going to be 4 minus 2 over 1, which is 2. And so our acceleration for the first 1 second is going to be 2. For the first 1 second, our acceleration is going to be 2 meters per second squared. And what about the next segment of the trip? Well, you can see we have 0 acceleration. Our velocity is constant. And so for the next segment, until 1.5, our acceleration will be 0, exactly 0 meters per second squared. And then finally, let's look until 3 seconds. What happens until 3 seconds? Well, after 1.5 seconds, what we have is another sloping velocity. This point right here is going to be, what is it going to be? That's going to be 3, negative 2. And so if we can go ahead and find the slope here, to be what? Well, negative 2 minus 4, and 3 minus 1 is going to give us negative 6 over 2, negative 6 over 2, which is, of course, negative 3. And so that's going to give us some velocity right here. So that's going to be negative 3 meters per second squared. And so now let's go ahead and confirm whether that's actually correct. If I've got this y-intercept here, what is this y-intercept? Well, this y-intercept is just going to be 2.5, 0. So let's go ahead and repeat that slope to see if we got the right slope. So we're going to get 0. 0 minus 4 divided by 2.5 minus 1. So that's negative 4 over 1.5. Negative 4 over 1.5. What's negative 4 over 1.5? That's 2.66. That might be, that's relatively close to negative 3. So at the end of the day, our acceleration versus time graph should end up looking something like a staircase, something like this. And so let's see which one of the answer choices matches our answer. So let's see, until 1 second, that's good. Until 1.5, and then boom. So the acceleration for 1.5 to 3 is more, the magnitude of the acceleration is greater than during the first 1 second. So I'm thinking the answer should be choice C. Let's see if that's what I got before. Let me go ahead and go to max displacement. Oh no, it's not max displacement. Velocity to acceleration. Let me go ahead and find what choice I selected.
Has a greater magnitude than our positive one, which is true. So our final answer is going to be none other than choice C.
Alright, that's it. So choice C, that's exactly what I selected. Let's see if that's indeed the answer. And boom, huzzah, we've got 5 for 0. So question number 5 is correct. Moving on to question number 6, shall we? So moving on to question number 6. So what does question number 6 ask us? Question number 6 tells us we've got a cannon, and this cannon fires some kind of a projectile. So here's my projectile, and we want to find the range of the cannon in terms of the maximum range. So this is a long and involved problem, but let me give you basically what you have to do. You know that the cannonball is fired at pi over 6. Now clearly that's not going to give you the maximum range. The maximum range, so pi over 6 is not going to give you the maximum range. What is going to give you the maximum range is 45 degrees. This of course is only 30 degrees. If we want 45 degrees, well, we've got to do what? 45 times pi over 180, and that's simply what? What's 45 over 180? So that's 0.25, so that's pi over 4. So pi over 4 is going to give us the maximum range. And so using that, you can find the ratio of the range when the cannonball is fired at pi over 6 versus the range when the cannonball is fired at pi over 4. And so let's see what answer that gave me for question number 6, the maximum range of the projectile.
Alright. Well, now we can just do whatever. Or if the reciprocal of that is root 3 over 2, and hey, that ends up being one of the answer choices, which is choice A.
Okay, so I got choice A for question number 6. So let's see if choice A is indeed correct. Choice A is square root of 3 over 2L. So if I come over to the solution sheet, and it is indeed choice A. Wow, okay, so they used a completely different formula. That's a formula you can either memorize, but you can also derive it, which I did during the video. So that's 6 for 0. So that means number 6 is correct. Moving on to number 7. So number 7, let's see what number 7 tells us. Number 7, we have a sled. So let me go to number 7. I'm pretty sure this is a momentum problem. So we have a sled traveling at 2 meters per second in the snow, and it has a total mass of 120 kilograms. So 120 kilogram sled traveling at 2 meters per second. So another child is going to crash into the sled with another speed, and we basically have to use the conservation of momentum, that Pi is equal to Pf, that the total momentum before is equal to the total momentum after. So sigma mvi is equal to sigma mvf. So if you end up doing that, what do you get for question number 7? Let's go ahead and check that out. So question number 7, let's see what I got.
I know that doesn't look like a prime, but of meters per second, which can also be written as 0.25 meters per second, which looks like choice A.
Alright folks, so it seems like the answer that I got previously was choice A, which is 0.25 meters per second, which is the new speed of the sled after it crashes into the other child. So let's see if it is indeed choice A for number 7. Number 7, it is indeed choice A. Okay, so we got 7 for 0. So question 7 is indeed correct. Let's move on to number 8. So number 8, what do we have? Right, so let's see if I actually got number 8 right. Number 8 is all about normal force and centripetal acceleration and centripetal force and centrifugal acceleration and centrifugal force. So let's see what I got for number 8. So number 8, the carnival roller, as I like to call it, also known as the centripetal force. So what did we get for that question?
If this method doesn't work, I'm a bit worried about. So, for my coefficient of static friction, and that's pretty much choice D, 0.53. All right, folks. So number 8, choice D.
All right, so I got choice D for question number 8, which is 0.534, the coefficient of static friction. Because of course the rider doesn't move according to his own reference frame. To an external reference frame, it does look like he's spinning around the centripetal roller. We of course know the answer choice cannot be E, 8.9, because the coefficient of static friction can never be greater than 1. Okay, so let's see if the answer choice is indeed choice D. So let's go over to the solution manual, and it's choice C. Alright, so we gotta revise that. Question 8 is the first question we've got wrong. It was inevitable, but it had to happen, and this is the first time it did. How about question number 9? Let's move on to question number 9. What does question number 9 ask us? Question number 9, we have a conservation of momentum problem once again, and let's see what I ended up getting for that problem. So question number 9, it tells us two balls basically collide with each other. It's definitely not in an elastic collision, but let's check out what I got for question number 9. Two pool balls colliding with each other. So by elimination, I got
choice B.
Choice B. So choice B tells us that statements 3 and 5 are correct, that the momentum in the y direction for both of the balls after they collided is gonna be 0, which makes sense because there was no momentum in the y direction before. How about choice 5? So that tells us the initial momentum for the first ball is equal to the final momentum of the first ball and the second ball in the x direction after they collided. So that means I got choice number B. So let's see if the answer to question number 9 is indeed choice B according to the solution manual, and that makes choice statements 3 and 4 true. Statements 3 and 4 true means that's choice number D, and so we have to revise question number 9. So we're going to come back to question number 9. Question number 9 is going to be a no-no. And finally, let's look at question 10.
Pause kore K now again.
Yeah, I'm on the last one.
Okay, baby. Hey, Demo. Oh, look like this.
Okay, so question number 10, we are asked to find the best value for the mass. We're asked to find the best value for the mass of the block, and of course this one's pretty easy. All you use is F equals ma. You plot the line according to the experimental data to the left in this table here. So let's see what I got for question number 10, getting the mass from the force. So skip the ad and let's see what we get.
This question is, I would say, the hardest question thus far.
Okay, so that's choice D. So choice D tells us that the average mass of the block is 20 kilograms. 20 kilograms. 20 kilograms for choice D. Okay, and let's see if that's indeed the solution. And no. So the last 3 questions were all strikes out. We got to revise all of those questions. 8, 9, and 10. We're going to revise them in the next video. Thanks for watching this reactions video to the FMOD 2008 exam, and we'll check you out next time.